Bismillahirrahmanirrahim. Dear viewers, now I am going to start tutorials on strap. So let's start. This is the starting window of strap. Here, if you have any previous model, then it will be shown here as a list. And if we want to get the demo models prepared by strap, we can go to browse, then C drive, strap 1 demo. Here in demo there are some models. This submodel is still hot rod, result elements, result combination, post tension slab, post tension beam, light gauge, steel frame, empty model, dynamic analysis wall, slab detailing, beam and column, sage load, bridge design result, bridge load. And we can change the current folder where we will do our model. Here this strap file I will choose. Here still now I have not created any model. Today I am going to start creating models. So here are some setup, color, miscellaneous toolbars and other things. Utilities, here are the utilities connected with this software. This DXF options, and here is help option. This is the language. You can change the interface language by clicking on this. Here are the language options. So let's start our modeling. Click on new model, write the model name, tutorial 1. Okay, and this unit you can change from here. See here the setup, you can change it. Default unit meter, kilonewton, you can change it to feet, inch or other. Okay, so I'll click on this meter, kilonewton. I will start with 2D frame, then we will go for 3D frame. So I'll choose this one, plane frame, and later on we will see also trace option. Here model wizard, grid line, user defined. In user defined you have to put the specific node coordinates to get the nodes, then connect the nodes to get beam. And here you can draw the grid line, and this is model wizard. I will start with this model wizard, this one. I will start plane frame, and other frame options are available here. This is continuous beam, we will go for plane frame. Number of bays I'll choose 3. Number of story I'll choose 2. Typical bay width I will choose 5.5 meter, and typical story height I'll choose 3.2 meter. Okay, here we can provide input the section and other section properties. We can provide standard frame section, standard member section according to the American standard, British standard, Canadian, and also user defined section. And here we can provide our dimension for I section and other section. For example, this I section, here we can provide the dimension, and we can choose the material properties. And here also available option is composite member. Here we can put the name. Okay, and now I will skip these steps. I will just create model, then I will define the properties. Skip all, and this load also I will skip, and this is the plane frame. Now this dimension is showing is in inch. I will change this one, draw dimension line parameter. Here you change it, you can choose it millimeter or meter. Okay, then end. Now click on this, it is coming as a meter unit. Now here I will select this vertical member as column and horizontal as beam, and I can change the dimension here. From here, let's check dimension, click on this. If you make it 7, okay, this dimension only, done. Now if I press ESC, then this frame will be adjusted with this dimension. This one I can also change to this is showing 6 because after the decimal point it is showing that rounding number. I can change it to 6 and press ESC, then frame will be automatically moved to that point. And click on dimension, again select this I can use it 8, then press ESC. And this height also we can change. This one we can choose 3.4, okay, this dimension only. And this one we can choose 3.0, okay. Now press ESC. So height adjusted. Here if we want to see the numbers after the decimal point, we can go to draw dimension line parameter. Here round off it is 1, we can click on 0.1 and we can change the digit after 0.2, okay, end. Now move this one and zoom in, zoom out, then it is showing the actual dimension. Here we can choose it 6.5, okay, and here we can choose it 7, okay. Now press ESC, then this members will be adjusted automatically according to the changed dimension, okay. After finishing the dimensions and other things, we can click on OK. Now we will get the option for node, restraint, beam, element, spin, copy, stage, submodel. All other option will be available here. We can create line using equation if we need curved line and any complex shaped lines, then we can use equation. This is a very great feature of this software. Now we will go for the member properties. First we will choose the restraint. Here already provided restraint. If we want to delete this restraint, click on this restraint option, then go to delete individual node, select this and this, then again click there, so the restraint will be deleted. Remember that you have to click on the individual nodes, and after finishing you have to click at the same point again to activate your command, so that all will be the selected nodes restraint will be deleted. In all cases like beam delete and member delete and other deletion, same way we have to do the deletion process. Now we can provide the fixed or pinned support. I will go for fixed first. Individual node, click on this. In assignment also in the same process, after finishing click in the same point again by the left side of the mouse. Now our restraint or support assignment finished. We can create new beam by going to beam, define, then select one node. Always in each step we should follow the left to right and this left to right and bottom to up to keep the local axis uh, accurate in the model. Here we can see the local axis for the members, and now we can release this member moment by using this option, moment release both beam end. Okay, click on OK, individual beam, this and this, again click here. So in this way we can release the moment from bracing. Now we can go for properties, define, double click here, dimension. I will go for RCC member, for example 20 cm width and 40 cm height. This SF2, this shear factor. We can, if you want to get suggestion for shear factor, you can press F1 so that here it will show the suggestion for shear factor. For rectangular, by default the shear factor is 0.85. Okay, we will use that one, 0.85. Okay, here another option, composite. If it is the composite member, you can select this one. Our material is concrete, we will use that one. For compressive strength, in strap we can define it later when we will assign the reinforcement for the member or plate. There it will be available the material nominal compressive strength of concrete and the yield strength of the steel. There will be available. There we can assign our compressive strength, but initially we can create or we can assign material properties concrete, steel, aluminum in this way. Okay, this is our concrete member. Okay, done. And another one we will define 20 by 60, 0.85, 0.85. Okay, and third one 20 by 70, 0.85, 0.85. Okay, now we will assign this beam section to member. Select the first one, assign individual beam, select this one, this one, this one, this one and this one, then again click here so that this 20 by 40 section assigned. Now go to second one, assign individual beam, this, 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 and double click here. Okay, so this assigned, and this one I want to assign more in this beam, this one, this one and this one. Again click here, done. Now third one, assign for interior columns, individual, this one, this one, this one and this one. Again click here to assign properties, then close. So our property assignment completed. We can see the rendered view from here. Okay, now we can select this one to see again line frame. Now here elements, for if we have slab then we can draw slab from here. spring. If we have spring properties for soil and other non-linear properties, we can assign from here. And this is for copy. We can select copy individual node, this and this, and select again. Now click on this. By coordinate we will go to 0 and upward we will go for 3 meter. Okay, then click on this. Okay, so these two not added. We can go for beam, define from here to here, here to here. Now we can assign property, this one, select this, assign individual beam, this one, double click, close. In this way we can copy node and member by coordinates. Now we will go for loading. Load here, new load like dead load DL. Okay, now define uniform individual beam, this and this. Again select this node. Load value, for example, we will provide 8 kilonewton per meter. This is upward, we have to provide negative value, that will be downward. Okay, direction here we can change the direction, type local. Okay, so this is the load we have applied. Now to finish this load case we will go to int load case. Now new load, for example live load. Okay, then you can select from here also individual beam, this and this. Click again. Here we can put 5 kilonewton per meter live load. Okay, so dead and live load we have assigned int load case. Now we can create load combination. We can go for defining load combination. We can go for combination library, this one, ASC ACI, we'll use this one. Okay, this we can choose an option combine after solution, or we can use solve as load case. This load combination can be used as a load case during the solution or calculation. We will use this one int. Okay, now we can go for solution. So click on it. For normal model, not complex, normal or small model, we can use this one, do not save. For complex and large model we can use this save matrix, and the solution method we can go for iterative for nonlinear and other analysis. So for this regular structure and for this small model we can go for these two options, solve. Okay, after finishing the calculation, this calculation time is less than 1 second. It will automatically prompt to result, draw result. You can see the result, this, then this moment has. Okay, then we can see the shear like this. We can see the axial force. Okay, in this way we can explore our result from here, and we can see the displacement also. Sorry, beam result displacement This is the displacement. You can go for geometry, beam, and you can go for we can make this member as tension only member. Okay, we can go to beam, then we can go to not property, we can go to release, then here for axial force no release, we can do it tension only beam. Okay, then okay, in this visual beam, this one and this one, click again. So this is tension member. In this way we can assign tension member, then go for solve. Yes, here we can see the result. We can see the axial force. This is the axial force. We can see the parameter result diagram. We can see the beam result by member wise. Draw beam. Okay, for display all the things. Okay, select for example this one. Here is the moment, shear, axial force and displacement. Again we can click on this. If I select this one, is the moment, shear, axial force and displacement. In this way we can explore the result. Now we can go to concrete option, then here the beam default parameter and reinforcement. Here is the concrete FC, that means compressive strength. We can select this one, and main reinforcement yield strength 415 MPa. Cross cover top bottom 30. Distribution, you can select the moment redistribution, and minimum reinforcement this one. Use support moment, support center. Okay, I am keeping as it is by default. Instead of FY we can use same 415. Here the number maximum this one. Reinforcement, calculated area, calculated deflection, here the limit, and here the seismic option, more frame type, OMF, SMF, IMF, and not proportion for earthquake. You can select these things. Okay, this definition for all beam, definition for selected beam, automatic definition of all beam. Yes, and now go for computation only for beam, for all defined beam. Okay, this is the result. You can print this one, and now BMD, that means for beam detailing. Click on here, open a new project, browse. This is the folder, our destination folder. Here we can write beam detailing details. Okay, now select the beam. Okay, so this beam drawing coming here. From here we can change the detailing or reverse. You can see different view. This is the views, and we can print this drawing to TXF file. We can edit the reinforcement from here. We can change shape, we can use crank bar, we can edit link. Here we can edit the link. Okay, and here we can see the required reinforcement by clicking on this. This is showing in square inch. Now we can go for column design. Select column, then here the parameter reinforcement 3000, this minimum bar diameter 4 and maximum 18, shear reinforcement same, tie minimum diameter 3. Okay, increment 25 millimeter, and number leg number 2, M3 and M2 number 2. Seismic OMF detailing, here crank, here are the others option you can change, then go to OK. Then define automatic definition for of all column, and yes, int. Okay, now compute. This is the result, required reinforcement result. Then we can go for detailing parameter. Here for beam reinforcement minimum left length, we can provide minimum left length 1.5 meter. Okay, individual beam this, then select. Okay, bend bar at end, we can choose all these parameters for the detailing. Okay, now we can draw our drawing. Delete, yes, delete, yes. We can create new table 1, then describe, and we can create new drawing, this one. So edit this table, individual beam, that means for column, select again. Okay, so this is the column schedule or column table. File, create text dxf file, limiter. Okay, here save, yes, you can see the dxf file, open with AutoCAD drawing. Okay, here is the generated drawing for column. So in next tutorials we will go step by step for 3D model from beginning to the end, up to the production of drawing and other things. So this is today is the first tutorial on step. This is like a overview from modeling to analysis and design. So stay with TCode BD for getting more updates and tutorials on stepwise and in more details.
Press the bell icon on the YouTube app and never miss another update.